ఇప్పుడు మిర్రర్స్ ది ఒక ఇంక్లైన్ ప్లేన్ లో పెట్టినప్పుడు సెంటర్ లో డ్రా చేద్దాం. మల్టిపుల్ రిఫ్లెక్షన్స్ when they are kept and inclined positions, when the two plane mirrors are kept inclined, okay, are kept at an incline, are kept inclined. So let us see, this is the mirror, and this is also the mirror, which is see here. Now let us say this at a point P for mirror M1, and this is the mirror M2. For M1, the point is at an angle of alpha, and for M2, the point P is at beta. We know that it will definitely make a circle, so I'll not make the circle. Wait. Now for M1, when it is looking at the point P at an angle alpha, the image will also be at angle alpha. This is also alpha. And when M2 looks at the point P also, it will be how much the angle will be beta, right? This we are clear. Next, so this M1, now the same concept for the mirror, M1, the image of M2, which is angularly displaced, will be acting as an object, Next, for the mirror 2, this is point to be noted. This is also point to be noted. For the mirror, M2, the image of M1, which is angularly displaced, will be acting as an object. Are we okay with the statements? Right? Same concept. In before one only what we have done, but we are seeing in the angular displaced. Okay, right? Now come to the mirror M1. This, what it is looking at the M2 side, the image of the angular displacement. Now you just see the angle, what it is making, alpha plus beta plus beta. So how much it will be angular displaced for the image will formation on the M1 side will be alpha plus beta, means this side it will be displaced from the mirror, that is alpha plus beta, that is you get 2 beta, right? Are we clear? Okay, next, now coming to the M2 side, the image of M1, which is angularly displaced, will be acting as an object. Now how much you see here, beta plus alpha plus alpha. How much you are going to get this side? It will be from the mirror. It will be alpha plus alpha. That is, you are going to get 2 alpha plus beta, right? This side you got alpha plus 2 beta. This side you get 2 alpha plus beta. Are we clear? Are we clear? Okay. Next. Now M1. It is looking the object, which is looking at the object of this side M2, which is acting as an object for it. That is angular displacement. How much? 2 alpha plus beta. That means from the mirror, you have to see alpha, alpha plus beta, alpha plus 2 beta, 2 beta plus 3 beta. Means this side, they are going to have how much? How much can you say? Alpha plus beta plus beta plus beta. So you are having how many betas? One, two, three. 3 betas from the mirror. That is 3 beta. Three beta. Right, 3 beta. Now alpha plus 2 alpha. That is 3 alpha. 3 alpha plus 3 beta. Are we right? Okay. Next, this M2 is looking at the M1 side, and which is angularly displacement from the mirror is alpha plus 2 beta. Now we count here. So beta plus alpha plus alpha, 2 alpha, 3 alpha. So you totally this side you are getting how much on the mirror? That is 3 alpha plus 3 beta, right? And the process continues, right? So this looks and the process looks a very time-taking process. We will go for the crisscross method, where it is very suitable for you and comfort. In order to get not to get confused, we'll go for the uh, good method, which is very easy method. That is crisscross method. To understand all these angles, you can go for the crisscross method, which is very comfortable in using that. Can I wrap this? Okay. Now let us see how we are doing. Let us go for the crisscross method. Now for M1 and M2, displaced with an angle, how much? Alpha plus beta. This side it is alpha and this side is beta. Now when you do the reflections, you see you get this side as alpha plus, when you do the crisscross method, there is alpha plus beta. So when you go this side, alpha plus alpha, 2 alpha plus beta. And you see on the M2 side, on the side of M1, you get beta plus beta, 2 beta plus alpha. So alpha plus 2 beta. Now again crisscross. Now this side, again you have alpha plus beta only. Now when you see this side, alpha plus alpha, 2 alpha, alpha plus alpha, 2 alpha, 2 alpha plus beta. How much you're getting? 3 beta, right? This side, 2 alpha plus alpha, 3 alpha. And this side you get how much? This side is 2 beta, 2 beta. Next again, in a crisscross, what you get? Again you do alpha plus beta angle. Now 3 alpha plus alpha, 4 alpha, 2 beta plus beta, you get 3 beta. Now alpha plus beta, you get here 3 alpha plus beta, that is 4 beta, right? And this continues, right? So you can choose this method and you won't get any confusions, right? Okay, now, am I clear with this? Now, based on this, we'll go the reflections. Now, then we'll do a problem, and it's from here it is 20 degrees, and here it is, let us say, 30 degrees, right? Let the point be P, and this is M1, and this is M2, and you do crisscross this, you do crisscross. Now, when M1, just put here M1, and this is M2. Now, the angle between them is 50. Now, you take here 20, and here you take 30. Now, you crisscross here, you give 50. 20 plus 50, that is 70. 30 plus 50, that is you get 80. Now, again, you crisscross, you get here, again, you add 50. 80 plus 50, that is 130. 70 plus 50, that is you get 120. Again, you do crisscross between 50. 120 plus 50, that is 170, and 130 plus 50, 180. And don't do the next. Do not do next, because the next reflections is not possible. Is not possible. We must stop. We must stop doing after 180 degrees. Right? Clear? Are we clear? This is a simple method you can go. Okay now? Right. Okay now? Next. And if are this correct or not, we'll check. Okay? Okay, by the long method. Are we doing correct or not? So, see here. This is 20 means this side also it will make from the mirror 20. No problem. And this side for M2, if this is 30, this will also be 30. 30, 20, 30. Right. Now, M2 is looking the object that is how much? So, 30 plus 20. 50, 50 plus 20. How much? It is 70. Right? 70. Now, M1 is observing 20 plus 30 plus 30. How much? 80 this side on the mirror. It is how much? 80. Right? Next, will now M2 is observing the object on M2 and the object on the M1. How much? So 30 plus 20, 50, 50 plus 20. 30 plus 20, 50, 50 plus 20, that is 70. 70 plus, sorry, 50 plus 20. How much? How much here? 50 plus 20, 70. How much, Nana? For M2. That is how much you are getting. Um, we need to get 20, right? So 30, 30, 20. How much? 50 plus 20, 70. 70 plus 8. How much I'm getting here? 150. 50. 50, yeah. How much? I got this set, right? Right. Fine, fine, fine. I'm right here. Now, when I look at the M1 side, now this will be how much? 20, 30, 20, 30. That is 30 plus 20, 30 plus 30, 60. Right. from the mirror M1, how much 30 plus 30, 60, 60 plus 70, that is how much I'm getting from the mirror, that is M2. How much? 130. Now this side 20 plus 20, 40, 40 plus 80, this side I'm getting how much? 120 degrees, right? I'm correct, right? We are getting the same results. Are we clear? We are getting the same result, right? Right. Can I wrap? So both ways, you are correct. Now, rotation of a mirror, the concept, rotation of a mirror, rotation of a mirror, rotation of a mirror. What do I see? Generally, make a note that the line is the incident ray is incident normally, which is making normal data. Then you say angle of incidence is equal to
ఇది అంత అర్థమైంది సార్ జస్ట్ అది అదొక్కటే ఉంది
angle of incidence. So it is not making any angle with the normal. So here it is 0 degrees. So when the line, when the incident ray, and the incident ray, and the incident ray is normally to the mirror, to the mirror, to the mirror, the angle of incidence will be equal to 0. Angle of reflection will also be equal to 0. This point to be noted. Next one is that the rotation of the mirror. Rotation of the mirror. Now see here clearly. This I go here like this. This is a mirror, and this is the normal. And you have an incident ray like this, incident ray, and you have the reflected ray, incident ray and reflected ray. And when this is the incident ray, and this is a normal angle of incidence, and this angle of reflection will also be R. R. Angle of incidence equal angle of reflection. Now the point is, when I rotate the mirror, she's saying keeping here, keeping the incident ray, keeping the incident ray fixed, keeping the incident ray fixed, having rotation of mirror by an angle theta. That's all. We are making just incident ray fixed, and what I'm doing here is just rotating the mirror. That is my situation to an angle theta. Now what do I do here is I take this mirror and rotate it this side. What will I get? Dinesh is having other plus. Okay, I rotate. Now this is my this is angle theta. Now when I rotate this mirror, I will have a new normal. I will have a new normal. The normal also will shift perpendicular to the surface of the mirror. The surface of the mirror. Now I rub here for a clear diagram. The clear diagram. Now the normal, new normal. Will be n dash. Will be n dash. For for convenience sake, I'm taking the R as I, because angle of incidence equal to angle of reflection. That based on the concept I'm taking. Now, here, and when it is being rotated to an angle theta, the mirror, the normal also will be rotating with how much? This also will be rotated with an angle theta. Now the new angle of incidence will be how much? For this normal n dash will be b I plus theta, I plus theta. Now the reflected ray also will be at an angle of I plus theta from n1. How much is that? That is I plus theta, I plus theta. Now this is the case. Now what I'm doing here is, if I want to find the angle of this area, now what I do is I take the angle of incidence, from this angle of incidence, from this, I take the angle of incidence, from the angle of incidence, I remove the angle of theta. I get this angle. How much is that? I minus theta, I minus theta, right? Now, in order to find of this angle, only this angle, of this angle, this area of the angle. Now what I do here is, from I plus theta, I remove I minus theta. Then I will get the value of this x value. How much is the angle which has made how much reflection after the rotation of the mirror. Now I can do simplification that x is equal to, I take from I plus theta, from I minus theta, that is I plus theta minus of I minus theta. I get x is equal to how much? I plus theta minus I plus theta. So plus I minus I cancel, theta plus theta, I get x equal to 2 theta. So we get the rotation of the reflection, the rotation uh, of angle theta, of angle theta will be the reflected angle, by 2 theta. Are we clear? Okay now, right? Or to make a simpler concept, I can go for the other one also. That is by just a simple method. That is, so they think this is the normal, and this is the incident ray, and I rotate it to an angle. Let us say this is the mirror. I'm making an angle theta. This is an incident ray here. Incident ray is fixed. Incident ray is fixed. So for this mirror, you will have a normal, which is making an angle theta for the incident ray. Definitely for this incident ray, there will be a reflection, that is of theta. If this is the angle of theta of angle of incidence, and for the angle of reflection also will be theta. So you can see the total reflected ray also here 2 theta. Simple, as simple as that. Not going for extra complication of calculation. It's just simple. To understand the previous one, you can go in this way approach also, right? The rotation will be 2 theta for the reflect, of the reflected. Are we clear? ఓకేనా? కాన్సెప్ట్ అర్థమైందా? అన్ని క్లియర్ గా ఓకేనా? నెక్స్ట్ వన్, నెక్స్ట్ వన్ నెక్స్ట్ వన్ the point is the very, very important, the distance the distance the distance traveled by the light ray, traveled by the light ray distance traveled by the light ray along the length of the mirror, along the length of the mirror, along the length of the mirror, along the length of the mirror is r tan theta. R tan theta, where r is the distance between the plane mirrors, between the two plane mirrors, right? In the two plane mirrors. Understood? Okay, how we are going now? How do we see this one? So this, consider this is a mirror M1, and consider this is as M2, and see here. Now the distance between them is R. Distance between them is R. Now see the calculations, and this is the reflections. R, 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 and this is also R and R head. And then externally one ray is coming. If this is inserted at an angle theta, this will also be theta, this is also be theta, this is also theta, this is also theta, and this is also theta, and this is also theta, this is also theta, and this is also theta, this is theta, this is also theta. Let the length of the mirror be L distance, and I go for only one reflection point. Let us say from this here to here, this is x, this is x, this is x, and this is x, 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 and this is also x. Total length will be, here I can write L is equal to nx. So by observing the less of one triangle, if I take one triangle, so we know that tan theta is opposite by base. So opposite, you are having x, the base is of distance of length is r, that is equal to tan theta. Therefore x is equal to r tan theta. Now I replace this length is how much? Length is equal to nx. This is in the first equation. If I replace, L is equal to n times, that is in place of x, I replace with r tan theta. R tan theta. And this is L is the distance, length of the mirror, and n says the number of reflections. For excluding the reflections, we need to take L is equal to, n is equal to L by r tan theta minus 1, right? You note it, right? Okay, now